Welcome to the notes on solving absolute value inequalities. So remember, absolute value, all right, it's a distance. It's always positive. And because there's two directions on the number line, there's going to be two answers because it's the distance from zero. So these are going to be compound inequalities. So we have to determine, is it going to be and or? So let's take a look at the first two. All right, the symbols here, whether it's less than or equal to. Is it an and or an or? Well, this is the best way I know to remember. All right, so if it's a less than sign, we say less than. All right, so anytime that there is a less than sign, it is going to be and, whether it's less than or equal or just a less than. So again, this will have that intersection symbol, all right there. So on the graph, we're going to be looking for intersection. So less than. Okay, now on the other hand, if it's a greater than sign or greater than or equal to, okay, doesn't matter which one, we're going to say it's great. We'll put a little parentheses here. Or greater. Okay, so greater than or equal to will always be a union or an or problem. Okay, which will have that symbol. Now that we know that, let's take a look at how we're going to solve some of these. So the first example right there, absolute value of x minus 6 less than 2. Remember, the first thing we want to do is we want to isolate the absolute value sign, which this one always is, just like with the equations. So I'm going to need two inequalities, just like the equation. So the first one, once we have it isolated, we literally rewrite it the exact same way without the absolute value sign. Now, watch what happens this time. So I'm still going to rewrite it, and it's a less than, so I'm going to put and I'm going to write the x minus 6. But now watch what happens. This right here, we flip not only the sign, we also make the opposite number. So it's instead of less than, it's going to be greater than -2. That's the big step for these. Otherwise, it's just like solving the absolute value equations. At that point, we solve them like we always do. Add 6. So this is going to be x is less than 8. And I come over here and I'm going to add that 6 again. It's the same steps on each side. So this one's going to be x is greater than -2 plus 6 is 4. So these are my two inequalities, all right, right here. Now, I need to graph those and put them in interval notation. So here we go. First, I'll do the 4. I'll put a point at 4. Oops, sorry, that was -4. All right, put a point at 4. All right, and it's a greater than sign. All right, so we're going to use parentheses. All right, so greater than 4 goes this way. All right, I know I can show you extends that way. And the other side, I'm going to have less than 8. So I put a point at 8. All right, again, this is 8 here. Less than, it's going to go this way. So where do they intersect? Right in between here. So now that we know that, we have to have a graph to put in interval notation. The answer in interval notation, parentheses, 4 through 8. All right, let's take a look at one more example. This time we have a greater than or equal to. So right away, I see this sign here, so I know it's going to be an or. Now remember, we got to isolate the absolute value sign. So let's do that before we get into our two inequalities. So to do that, I'm going to add 7 to each side. Now remember, just like equations, if it ever equals or it's the negative sign is the absolute value sign is isolated and it's a negative, there'd be no solution because distance can't be negative. But you got to wait till you isolate it to find that out. So now that I add 7, you'll see that this becomes absolute value of x over 3 minus 1 greater than or equal to 2. Okay, so now it's isolated. It's the constant on the right-hand side of the inequality is positive, so there will be a solution. Now I need to rewrite it, the two inequalities. So the first time I rewrite it, we just rewrite it without the absolute value sign. So I'm gonna scroll over here to rewrite that. All right, so I'm gonna rewrite it as x over 3 minus 1 greater than or equal to 2. I'm gonna write or, and over here I'm gonna have again that x over 3, so we even got fractions in this one, minus 1. Now again, here's the key. I have to flip that, so it becomes less than or equal to, and this now becomes -2. Okay, now that I solve it just like we always do, add 1, and I can really do that right over here as well at the same time, because it's going to be the same steps. So I'm going to have x over 3 greater than or equal to 3 Okay, and then over here, I'm going to have x over 3 less than or equal to negative 2 plus 1 is negative 1. Now, we want to get x by itself. It's being divided by 3, so this is where we have to do the opposite. We have to multiply by 3. Multiply by 3, we know we're going to do the same thing over here. That's going to cancel out. So when we do that, we're going to have our final answer as x greater than or equal to 3 times 3 is 9, or we're going to come over here. All right, we're going to have x less than or equal to negative 3. So there's our two inequalities. Now let's graph those and see what it looks like. So it's less than or equal to, so we're going to have brackets. So I'll do the 9 first. I'll put a point at 9 right here. All right, it says less than or greater than or equal to 9. So greater than or equal to. I'm going to kind of do it underneath here so we can kind of have an idea where this graph goes. That goes that way. Okay, less than or equal to negative 3. So negative 3 is right here. Less than or equal to goes that way. Okay, they don't overlap. It's an or. So here's my final answer on the number line. We're going to shade all of this. And we're going to shade, oops, and this needs to be a bracket here, sorry. And a bracket here. Okay, then interval notation left to right. So I'm going to go parentheses, negative infinity, because it goes negative infinity all the way to negative 3. We put a bracket. Now I want to put the union symbol instead of writing or, because you'll see that in the homework. And then we go to, it goes to 9 to positive infinity. And that's how you solve absolute value inequalities.